This lesson is dealing with the normal distribution. In this lesson, we're going to talk about percentages and the area under the normal distribution curve. So our objective is I can calculate percentages of a normal population. So when we look at a normal population, mu is right in the middle of the symmetric normal distribution. And so the data, half of it's on the one side of the mean and half of it's on the other. So as we look at this graph, we can break it down with our standard deviations as well. When we look at these standard deviations, we have to look at them and put into these different categories what percentage of population goes in each. So the area under the curve equals the percentage of data in those parameters, whatever we're talking about. Here we're going to talk about z-scores, like between different z-scores or underneath a z-score or above a z-score. So all those sorts of things we're going to be using this information. So looking at this, what we want to do is we're going to talk about how we're going to use the percentages in these different regions. So if we have mu right in the middle, remember 68% of the data is between one standard deviation above the mean and below the mean. That means about approximately 34% of the data is in this region and 34% is in this region. And so we can use that. So if I were to ask what's the amount of data in between the mean and one standard deviation above the mean, we'd be able to say 34%. Okay. Now the next category, when we look at the next one, we're going to go to the two standard deviations. So between one standard deviation above and two standard deviations above is about 13.5% of the data. That's 13.5. So that's the same thing here because it's symmetric. 13.5% of the data here between one standard deviation below and two standard deviations below. Now it gets smaller, notice because the graph is getting smaller, the area under the curve is getting smaller. So this area here, I'm going to write it above it, is 2.35% for this region, and same thing over here, 2.35% for this region. All right, and the last one above 3 standard deviations of the mean, so going out to the further reaches, we have a very tiny area. This area down here is 0.15%, less than a percent. Same thing down here, this is going to be 0.15% of the data in this area below 3 standard deviations below the mean. So we can use that information to come up with what are called percentiles. Percentiles are the percentage of data, the percentage of data less than or equal to a data value. Okay, so if we've got a data value here, for instance, this percentile would be all this area down here. Okay, so it's the percentage of data down there in that region. Now, if we were talking about, for instance, 2 standard deviations above the mean, so here we're going to talk about z-scores. So z-scores represent the number of standard deviations above or below, positive above, negative below the mean. If we're talking about the amount of z-score of data in this region over here, what we have to do is we have to add up all of these regions from 2 down. Now, let's be strategic about this. From mu down, from the mean down is 50%. So I'm going to start here and just say 50% of the data to start with, plus, and then I'm going to add this 34%. And then plus, I'm going to add up to 2 standard deviations above is this 13.5%, and then it stops. Okay, so if we add all of those up, our percentage ends up being plus 34 plus 13.5, and we get 97.5% of the data will fall below 2 standard deviations above the mean. Okay, so that's the percentile, 97.5. Now, if I were instead to ask the question, what would be the data above that, okay, what would it be above 2 standard deviations? All you'd have to do then is add these two little ones. You'd have to add 2.35 and 0.15. So let's do that for this one here. If we were at -1 standard deviations, okay, if we were gonna go with below it, all you'd have to do is go 1 standard deviation below, add this 13.5, this 2.35, and the 0.15. Or let's go ahead and talk about what's the percentage of data above it, okay? So above one standard deviation below the mean, we're going to take this 34%, and we're going to add to it the 50% for the rest of it. You don't have to add all those numbers because that's half the data over there. So add to it 50%, and so you get for that 84% for that. Now, what if instead I'm asking you to find the amount between 1 standard deviation below and 3 standard deviations above? So we want to find the amount between these two. All right, now there's 2 ways to do this. You could add up all these regions here from this one below and then these down here, or you could do all the way up to 3, whatever that is, and subtract off whatever is below it. So sometimes you just have to use kind of a common sense as to which one would be easier. Here I think it's easiest to go ahead and add this 34%. I'm going to add to it this 50%, the whole thing. So that would get if it was going above that. And then what I'm going to do is subtract off what's above 3 standard deviations. I'm going to subtract off this little 0.15%. So let's see what we get when we do those. So you're adding regions on. In this case, I'm going to subtract a small region off of it. So 34 plus 50 minus 0.15 gets me to 83.85. 83.85%. So this is how you do it using the z-scores and the typical ones we know with of 1 standard deviation above or below, 2 standard deviations above or below, 3 standard deviations above or below. If the question asks you for information with other z-scores, like say 1.5, you do have to use on your calculator the normal CDF, and that's for a different time to talk about how to use the calculator for that. But the normal CDF function, which is normal cumulative distribution function, that's a way to figure it out with the non-typical ones like we're using here. So this is how, if you want to find the percentage of data in a certain population that's normal, you can use your normal curve like this in these percentages to add or subtract up values to get between different z-scores. You can convert to those z-scores or just use your data values to get that, and that will get you the percentage of data in that range.